if we want to find the integral of x cubed square root of x to the 4th plus 5 with respect to x between 1 and 2, we've got a definite integral. We've got values of x ranging from 1 to 2. It looks as though we've got a function of a function going on here. We've got the square root, which is a function in itself, of another function, which is x to the 4th plus 5. So if we let u equal that function, so let u equals x to the 4 plus 5. So from there, we've got du dx is equal to 4x cubed. And we can make dx the subject, du over 4x cubed equals dx. Okay, so we can substitute for x to the 4 plus 5. We're not going to substitute for that. We're hoping that'll cancel out. X to the 4 plus 5, and we can do a substitution for dx. But because we've got a definite integral between 1 and 2, these are actually x values, and we're hoping we're going to do an integral with respect to u. So we've got to make these into u values, and we can find the corresponding u values when x is equal to 1. We know that u is equal to x to the power of 4, so 1 to the power of 4 plus 5, and that's equal to 6. And when x is equal to 2, u is equal to 2 to the power of 4 plus 5. 2 to the power of 4 is 16, plus 5 is 21. So because we're going to, hopefully by substitution, just have an integral with respect to u, these values here can be from 6 to 21 instead of from 1 to 2. So we'll just write the question out again. Integral between 1 and 2 of x cubed square root of x to the 4 plus 5 dx is equal to the integral. Now we just said we need u values here between 6 and 21. X cubed, we hope will cancel out. Square root sign is to the power of a half. So when I do calculus, when I've got a radical sign or a square root sign, I like to make it into index powers. So this will be x to the 4 plus 5 is equal to u. So that'll be u, square root of u, which will be the half. And then we've got to do a substitution for dx. dx up here is du over 4x cubed. The x cubes will cancel out. We've still got a 4 in the denominator. We'll bring it out the front, so there'll be 1/4. 6 and 21. And the rule for integration is just add a power on that power. So that'll be, we're going to integrate with respect to u. So that'll be u to the power of, if you add 1 to a half, you get 3 on 2, all over 3 over 2. So once again, we can take this 3 on 2 to divide by a fraction. So divide by 3 on 2 is the same as multiplying by 2 on 3. So this is dividing by. So we will get, multiplying by 2 on 3 will come out the front, so you get 2 over 12. 2 over 12 is 1 on 6. U to the 3 on 2, 6 and 21. So once again, this is divide by 3 on 2. Your rules with dividing fractions is to change the divide to a times and flip the fraction, which becomes 2 on 3. So instead of dividing by that, we can multiply by 2 over 3, bring it out the front, and you get 2 over 12. 2 over 12 is 1/6. So now doing the substitution in, so that'll be 1/6. Substitute the top one in first, 21 to the power of 3 on 2, minus 6 to the power of 3 on 2. Now, since this course is geared to be without a calculator, you would not be expected to go any further than that. So just summarising again, when you've got a definite integral, the key difference when it's an indefinite integral, in other words you use plus c, when you don't have values here and you have plus c, the only difference, you still apply substitution, but you actually have to replace these two values with the corresponding new values, and it should fall out for you.